So let's talk just a little bit about pKa tables. Now again, and almost all these acid-base videos are going to start with our simple acid-base equilibrium. Great, there's our generic equilibrium. Now what do you, as I said, we want to talk about pKa tables. So what do you encounter in a pKa table? They're often within the inside cover of a textbook. You can find tons of them online. Just Google pKa table. But they'll always have a column that'll show what is the acid, and of course not just one acid, but typically an entire column listing of acids. And then they'll always show the conjugate base. And then they'll always list what the pKa value for that acid is. So this is our acid. So this is what we would show as HA. Then they dispense the formalities of showing H2O and H3O plus because they show up in every equilibrium. There's no reason to put it in the table, but sometimes it's nice to list what is the conjugate base, and for us that's A minus, and then the pKa value. So let's list something like HCl. HCl we're familiar with as an acid. The conjugate base of HCl is Cl minus. Turns out the pKa value is around -7, and sometimes it depends on where you look. Sometimes I've seen it as high as -5, but -7 is a pretty typical number. So what do we know about this -7? Well, pKa is equal to the negative log of Ka, and if you go through the math, as it turns out, Ka for this is equal to 10 to the 7th. So for 10 to the 7th, that means the equilibrium is very, very strongly to the right. So this acid, HCl, acts by giving up its proton and forming lots of H3O plus and a high concentration of the conjugate base. This is a very stable conjugate base, very stable anion, and that allows this anion to exist without being attached to its proton, so the proton comes off very easily and is picked up with water. So this is just an overly simple example of a pKa table where we just have a single entry, but normally you'd have many different acids listed and you could look at pKa values. Unfortunately, we're going to look at molecules that don't always have pKa values, or it's going to be inconvenient to find them. So we need to be able to look at things and make some judgments on our own. It's not just about looking up values. It's about using what we know about structure, in particular, what we know about charge stability, and being able to make judgments on our own. So we're not simply looking up values. We're critically thinking about how the structure of our anion will affect its stability, and that'll give us insight into how the reaction is going to work.